Hi class, today we are on Saxon Book 3, Lesson 71, and today we are going to talk about rectangular prisms. So, some of you probably have some blocks at home. I have these. I actually have a bag of different shaped blocks. We don't call them blocks anymore. In third grade math, we call these geometric solids. So geometric is our word for different shapes, and these are three-dimensional, meaning they have length and width and height. I can hold them in my hand. They're not just drawn on paper. But the one that we are going to focus on today is this one. I'll try to hold it at different angles for you so that you can see it all. This is called a rectangular prism. I have another example of a rectangular prism here. You might recognize this. It's a tissue box, an unopened tissue box. So all the sides are closed versus the open one, which would have a hole in it. This is an example of a rectangular prism. So there are a few things that you need to know, some vocabulary words that go along with rectangular prisms. So in a few minutes, I'm going to show you how to draw a 3D prism. When you do that, we'll have you label the parts like I have on the board behind me. So first we have the vertex. The vertex of rectangular prisms are these corners here, where all the sides meet. So there's more than one vertex. Vertex is the word for if we have one. If you have more than one, we call it vertices. So this rectangular prism has several vertices, or I can point, there is a vertex, there is a vertex, there is a vertex, there is another vertex, and then on the other side we have four more. All of those corners, that's called a vertex, okay? The edge, really that's the only word we can call it, I think. The edge is where the sides meet. This length in between the vertices here, that's an edge, 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 and then holding it this way, another edge, edge, edge. So that kind of line that makes up the rectangular prism, those are called edges. And then finally we have the face of the rectangular prism. So this rectangular shape, that whole thing is called a face. So we have a face here, 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 and then we have faces on the ends as well. So those are the three vocabulary words that you will need to know with this lesson. When I show you how to draw the shape, I'm going to have you get your math dictionary out. You don't have to write a definition for them. If you would just draw it and label, show me an edge, show me a vertex, show me a face, and you'll have that diagram in your dictionary for the future when your math book asks about those words. Okay? So our first example wants to know, how many faces does a box have? So right here's my tissue box. We are going to keep track of the faces. So I'm going to start here so that we don't count this one a second time, and I'm just going to rotate it. So one face, two faces, three faces, four faces. Oh, back to the beginning. We don't want to count that again. So we have four faces wrapping around it. Then we have five faces, six faces. How many faces does a box have? It has six. It takes six faces to make a box. All right, the next example wants us to compare. So I have this rectangular prism that I've been showing you, and then I have this one, and I'll try to hold it again at different angles so that you guys can get a good picture. So what is different if I hold them side by side like that? What's different about these two? This one's a little bit taller. This, if we look at this shape, what do we call this shape? That's a rectangle. What do we call this shape? That's a square. So they're both technically rectangular prisms, but we would never call this one a rectangular prism. It has its own special name, just like how a square is technically a rectangle, but we don't call it a rectangle, we call it a square. So this one, where all my faces are square shaped, all 6 faces are shaped like a square, this is called a cube. So a cube is a rectangular prism where all the faces are square, versus this rectangular prism, none of my faces are square, and certainly not all of them. So rectangular prism here, cube here. So let me show you the fun part. How do we draw these? Get my little whiteboard here. So I have a little trick that I have developed over years of teaching 3rd grade. The first part of the trick is we draw a rectangle. So that's all you do. You can grab a whiteboard or a piece of paper, draw a rectangle. Leave space around your rectangle on your paper. Don't draw your rectangle up here in the corner because that'll make it difficult to do the second part. So you draw a rectangle, put a dot right there in the center of your rectangle. And now you're going to draw a second rectangle that's congruent to this one. We want the same size, the same shape. Oh, excuse me, starting with the dot, this is going to be a corner. So I'm going to go up about the same distance as my height here. So I end up going outside of that first rectangle. Then I'm going to go over about the same distance as what I have here. So I'm going to go past the edge, and then I just finish that off as a rectangle. So this is what you want when you have your 2 congruent rectangles. And then the last thing we do is we connect all 4 corners. So watch what I do here. I'll start over here, and I'll draw a line from corner to corner, or vertex to vertex. And then right here, I'll draw a line from vertex to vertex. Can you see it coming together? Then over here, vertex to vertex. And finally, inside right here, vertex to vertex. And see how you have a 3-dimensional rectangular prism on your paper? Okay? So once you have this picture in your math dictionary, then be sure to label 1 vertex, 1 edge, 1 face so that you have that diagram. I'm going to show you how to do this again with a cube because it's the same process. We start by drawing a square. There's my square. You put a dot in the middle. And then from that dot, we make another square. Try to make it as congruent as possible. And then connect your 4 corners. And there's your 3-dimensional cube. Oh, I didn't quite connect it there. There you go. Okay, 3-dimensional rectangular prism, 3-dimensional cube. If you follow that little trick of mine, you can make a 3-dimensional figure anytime you need to. So your lesson practice for today is on page 387. You can turn there and do them ahead of me or just follow along as we do them, but I want you to try to answer the question before I give away the answer in the video. So problem A says draw a picture of a transparent box. So if you followed along with me before, you've already done that twice. Go ahead and try it 1 time now without my directions. Hit pause, draw your box, and then come back for the second problem. Okay, if you've got your box drawn, you can go show a parent, look how good I did. It looks like a 3-dimensional box. That's a pretty awesome skill for a 3rd grader. And we're going to move on to problem B. It says, how many vertices does a box have? Go ahead and count them up right now and yell your answer at the screen. How many vertices does a box have? So we're going to use one of my pictures so that I make sure I don't count any of them twice. So let's use this picture. We have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices in every box. In every rectangular prism, we have 8 vertices. Did you say 8 when you counted them on your own? Nice. Problem C says, how many edges does a box have? My brown marker didn't show up very well, so I'm going to try to grab a blue one. How many edges does a box have? We'll use the same one. So we have 1 edge, 2 edges, 3 edges, 4 edges on the bottom, 5, 6, 7, 8, counting the edges on top, and then we have to connect the top to the bottom, 9, 10, 11, 12. So there are 12 edges in a box or in a rectangular prism. And finally, it says, describe a cube. So what I want you to do is go to a homeschool parent and describe the cube to them. Don't tell them it's a cube. Say, I'm going to describe something to you, and I want you to guess what it is. And see if you can get them to say cube without telling them what it is. So remember, this is a cube. The special thing about a cube is that all of its faces are square, congruent squares, in fact. I hope you guys have a great day, and I will see you again soon.